We'll get to that later. Good morning, folks. Okay, adjust that for your time of day, I suppose. Hi, I'm Tom Melendez, and this is the next in a series of short videos showing you how you can use Ansible with Google Cloud Platform. If you saw our first couple of videos, you'll recall the theme of these videos is that I'm a DevOps engineer using Ansible to manage infrastructure for our satellite imagery project. Earlier, I received a text letting me know about an unexpected traffic surge on our imagery website, but we're autoscaling with Google Cloud Platform, so I could keep playing my game. Dylan Silva is here from Red Hat again, joining me to talk about how we're using Ansible to manage our infrastructure.
Hi all. Tom, thanks for having me again. Can you describe the setup, and then I'll be happy to walk us through the Ansible playbooks like we did last time.
Sure. Google Compute Engine not only has VMs like we saw in the last video, but it also has lots of networking capabilities. In this video, we'll walk through how we're using GCE's HTTP load balancer to create a globally accessible, cross-region, auto-scaling website running on managed VMs, all provisioned with Ansible. I'm going to kick off the provisioning process and then hand it over to Dylan to walk us through these Ansible playbooks. You can watch our first video if you need tips on setting up Google Cloud Platform or Ansible.
Okay, so while that's running, let's take a look at some of the playbooks, shall we?
Sure. Let me open it up.
All right. Okay, so now that that's open, it looks like we have a playbook that executes commands from localhost and includes some variables from various files like last time.
Right. You can run this command from anywhere as long as you have the proper credentials.
Okay, cool. So first, we're creating a couple of managed instance groups. We set the name and zone as well as the starting size, and we're also setting the instance template that should be used in building these new instances. And then it looks like the managed instance group, also where you configure the autoscaling policy, is here as well.
Yes.
Okay, so that's one of the greatest features that I think are there about scaling applications with Google Cloud Platform. Can you tell us a little bit more about autoscaling in depth?
Okay, well, with autoscaling, you can have your host scale up or down based on a policy you configure. The policy can be based on things like CPU utilization or what fraction of the load balancer utilization the instance group should handle. You can even define policies using custom metrics if those don't suit you.
And details are in documentation, right?
Right. To keep it simple, we went with CPU utilization. This policy basically reads, scale accordingly to keep the CPU utilization on the machines under 80%.
And that's it? GCP will scale up those instances for you?
Yes, to the max number of instances that you specify.
That's great. So I see we specified two managed instance groups here with basically the same configuration.
Very true. We want it to be explicit here, but one might consider using a looping construct like with items or with dict.
And then finally, for our managed instance group, we have name ports specified.
Yes, those are where the backend service will send the traffic to.
Great segue. So let's talk about backend services. What is a backend service for?
Basically, a backend service is a collection of instance groups. The backend service lets the administrator treat all of these instance groups as a single entity in terms of serving capability.
So what do you mean by that?
Well, we've configured the managed instance groups to scale up based on CPU previously, but really we haven't talked about how much traffic we want them to handle. By grouping these instance groups into a backend service, we can set additional configuration as well as a health check on the whole entity.
And then you can have multiple backend services, I imagine, right?
Right. This lets admins build out their desired infrastructure, placing groups of instances where it makes sense for them and determining how much traffic they should handle.
Wow, this really seems super powerful.
It is. Another powerful and customizable feature is the URL map, which we have up next.
So now it looks like all of the configuration here is pretty minimal. It looks like just giving it a name and handling the backend service that we created. What is URL map for anyways?
You're right. In this case, and for many applications, simple configuration such as this is fine. In essence, the URL map maps the URL to a backend service. We don't do it here, but you can route different paths to different backend services.
So for our configuration, this playbook is basically saying map any URL to the default backend service, right?
Right. Next is a target proxy, which terminates the connection from the client and routes the request to a URL map. In this case, we're using an HTTP proxy.
So we could then change that to an HTTPS proxy and then still use the same URL map though, right?
Correct. In that case, you would also specify the SSL cert in addition to a URL map.
And then finally create a static IP address and a forwarding rule.
Right. Up until this point, we've built out the load balancing capability. Now we're creating an IP address and mapping to the proxy.
Gotcha. So when a client makes a request to this IP address on that port, the proxy is going to handle it.
Yep. And that's the entire configuration for a global load balanced web application.
So cool. Not a whole lot of configuration then. How'd the provisioning go?
It was done a lot sooner than we were. The load balancer was created successfully.
Great. So how does this look in the web console?
Let's take a look. Okay, opening up the dashboard, then we click on networking, then load balancing. Let's click on the advanced menu down at the bottom here, which gives us the component breakdown that mirrors how we built it up with Ansible. We see the global forwarding rule and the IP address it maps to. Under target proxies, we see the proxy name, the type of proxy, and the URL map to apply. Clicking on backend services, we see our backend service. Let's click on that.
Hey, cool, traffic. So we can see how much is being served out of each instance group here.
Right. I generated this traffic with a bash one-liner using curl. One instance in our east region, one in the west, just to demonstrate the graphs. Interesting to note that the user can click right here and adjust the settings if they like.
So, but of course, those are going to be overwritten by the playbook the next time because of the desired state of the system.
Yep, of course. Well, that's it. Another quick in and out video showing Ansible and GCP. Thanks, Dylan.
You're welcome, Tom. Hey, it's been great showing viewers how to use Ansible with Google Cloud Platform. Are you up for another one?
I sure am.
We've got more to show you, folks, so we'll see you next time.
And don't forget to check out all of our Ansible modules at the URL in the description below.